Hey folks, welcome back to session 2 of Social Networks and Health. Leanne Tucker is a PhD student in sociology. She is what year are you now, Leanne? 5, I think?
Going into 5.
Going into 5, that's right, yes. And she's writing a brilliant dissertation on the dynamics of social networks and what leads to stable versus unstable relationships amongst youth, and the way in which that affects their health and other behavior outcomes. So she's also going to spend the day talking to us a little bit about Intro to R and Rstudio. So Leanne, take it away.
Cool. And can y'all see my screen, the slides? Okay, cool. So this first session is just going to be about R basics, mostly for people who've never used R before. We're not going to get into network stuff until the next session. So I'm going to go briefly over some of the stuff that was in the scripts that were written by Maria Cristina Ramos Flor, who's a DNAC alum. Those go into way more detail, but this stuff is, I think, useful to hear as well as see on those scripts. So I'm going to go over what R is, the difference between R and RStudio, what packages are, how to install them, getting started with R, and some tips and resources for people who aren't familiar with R. That should help. Feel free to stop me at any point with questions or clarifications, or if I'm talking too fast. And then I think we have Bernard monitoring the chat again, so you can put stuff in there too if you don't want to ask questions out loud. So a bit about R, it's an open source software, which means that it's free and has an entire community building it up and making these packages. The upside of that being that it's free and useful across all platforms. The downside being that it's not really regulated as much as other software like Stata or SAS. So it can be a lot more frustrating to learn and keep up to date with what's going on with all the packages changing. It's a language and its own kind of window and environment. So like all coding programs, R has its own syntax and grammar, which you'll have to get used to if you're used to another coding software. You might hear that it's an object-oriented language. All that means is every time you do something in R, like load data or run some function, you want to assign it a name, which we call an object. So these objects can be data and code, data in the forms of rows and columns, and code in the forms of procedures or functions. And then finally, R has a really steep learning curve. It's going to be frustrating if you've never used it before. I can tell you from my own experience, when I moved from Stata to R, I frequently felt like throwing my computer out a window during like maybe the first 2 years. And sometimes I still do. Just be patient. And again, I think Jim has echoed this, but just ask us any questions. There are really no dumb questions with R. And there's a lot of information to show, and those of us that have been using it for a while will forget to relay some basic stuff that will be not obvious if you're using it for the first time. So you'll hear us in the workshop refer to R. The program we'll actually be using to work with R is called RStudio, and you can think of R as the engine of a car, which by itself is useless to most of us. And then RStudio is the dashboard and interface you use to interact with R in a coherent way that is open to the masses. So every time you use R, you're actually going to be opening RStudio, but you have to have both installed for it to work. When you open RStudio, this is the window you will see. It's separated into 4 panes, and each have their own job. So I'll go over those a little bit. The first one up in the top left is the source pane. This is like your text edit or your notes app, or in Stata like a do file. It's where you'll write all your code and save it so you can use it again next time. And then second, right below it, we have the console. This is the engine of R. Anything you run in the source code will be processed through this engine, and you'll see some output here as well. And then third, in the top right, we have our environment and history pane. The environment shows you what objects you currently have in your RStudio or what you've already created. And the history tab will show you the list of commands that you've run during this session. And we refer to an RStudio session, that's the time you have RStudio open. So every time you open RStudio, that's a new session. And then finally, in the bottom right, you have a bunch of stuff in the tabs. It's your files, plots, packages, and the help pane. To go into a bit more detail on these, this is what the source pane looks like when you have an R script file open. So in the script for this workshop, you'll see a lot of these like green text, this means it's a comment. So even if you run it, it won't do anything, or will just ignore it. And you start all comments with a hashtag, and you have to do that for every line. So this is just a really small example, not network related, of what some R code looks like. MT-cars is like a sample data set that comes loaded in R. Again, when we talked about objects, you can see one here down at the bottom. I ran a correlation between like horsepower and weight, and I wanted to keep that number stored. So I assign it to an object using the arrow operator, which is just a less than sign and the dash. I believe that Maria Christina's code for this went over these operators a lot more in detail, so you can check out her stuff for more of that, but also feel free to ask any questions about what these mean. Okay, so that's it for the source. And then for the console, you'll see at the bottom this then greater than sign. That means R is like done doing whatever it was doing and it's ready to run something. If R is busy working, up in the right, you'll see this like stop sign, and I would just like don't do anything if that stop sign is going. Otherwise, if you try to do too much, R will crash, and that is not fun. In the console, you can run like small calculations. Like here, I just did a simple arithmetic, and it'll output answers, or if you want to like really briefly look at something in your data. But I would do my best not to do stuff in here just because it will not save anything. So this is really just for like very quick glances at stuff or really simple calculations. And then the environment pane again shows the objects you have stored in the R session. So we loaded the MT-cars data, so you can see that here. And that object I made of the correlation between horsepower and weight is stored here as a value as well. And so you can reference those in your code and R will pull it out. If you want to like physically look at your data, like a little Excel sheet, if you click on the object in the environment, it'll open up a little spreadsheet in your source code, just like it would in Stata or SAS or just an Excel file. Okay. Then last part, all this stuff here, the files tab shows your current working directory. For those that aren't familiar with that term, working directory refers to the folder location you've told R to work from. R will only pull stuff from whatever folder you're currently working with. So anything you save will go here unless you specify otherwise. Anytime you try to pull data, it'll go check your working directory to see where that is. I would recommend creating a folder for this workshop and for every project you do, and just making sure that all of your files are in there so that R knows where to save and where to pull stuff from. Then the plots tab, anytime you run code from your source pane that creates a plot, it'll show up in this bottom right tab. There's a zoom button here that will allow you to open the plot in a bigger frame in a separate window. And you can also use the export tab to save it as a image or JPEG or PDF, whatever you want to do. And that'll also, if you save it, typically automatically go to your working directory unless you specify otherwise. On the packages pane, you'll hear us talk about packages a lot, like iGraph and various data cleaning packages. This will show you all the stuff you've already installed in R. R comes with a bunch of packages, but you'll have to manually install some as well. Anytime you see a check mark, it means you have that package loaded. If it's not checked, that means it's not loaded, and so the functions won't work until you load it. You can manually check off packages if you want to load them, but it will also show you how to do it within the code. And two more, the help package is what it sounds like if you want to look up what a function does or what the arguments are to go into a function or an overall package. You can search here, and then within the package itself, you can search a topic. The documentation for packages are kind of a hit or miss whether or not the creators have done a good job in terms of explaining how to use them. iGraph I find very useful, the help package. I think most of the packages we use here, I think the documentation is pretty good and pretty easy to follow. And then lastly, in this bottom right-hand pane is the viewer, which I don't think we're going to use that much here, but just so you know what it is, it allows you to preview any HTML outputs. So like I just made a table of our MT-cars data set, and it helps you make some like prettier tables if you need them for your publications or for your online for your website. And you can export them into a document or copy them into a Word doc if you need them. Okay, so that's the general window of our studio. I want to talk about packages a little bit. So packages in R are made by users. They bundle together code and data and documentation so that it can be shared with others. So that's why it gets a little bit frustrating working with R, because different individuals are making different packages. And so there's not really one person synthesizing them all together. So packages do make certain routines easier, and some do work really well together with people doing work building them together. So like cleaning data or doing specific methods, like we'll do network analysis with iGraph and I think SNA. When you first open R, if you've done our little intro script already, it installed a bunch of packages for you. So you should have all those installed, but you only really have to install those once. But every time you open R, a new session, you'll have to reload the package by calling the function library or by doing the check mark on the packages tab. So you can think of packages like a light bulb that you install once, but then every time you want to use it, you have to switch it on. In the future, you may have to update packages if the users update them, if the creators update them themselves. That just means you have to run install packages again. So just changing a light bulb, and R will tell you if it's updating a package before you do it. So, and these are just names of the packages I use frequently, and I think we'll be using in this workshop. If you have used them, if you've gone through all the scripts, not an exhaustive list, but just kind of explaining what they do. You'll see a lot of people name their packages with a pun using the letter R. It's become sort of a habit of everyone. Okay, so once you have both R and RStudio installed, you should be good to go, and hopefully you've all been able to run that test script. Every time you open RStudio, I've mentioned this before, the first thing you want to do is set your working directory. That's like one of the most common problems that we run into when we get questions. Again, I would recommend keeping a folder for each project, having a folder for this workshop, and even creating an R project file is useful, because then you can just double click on that and we'll open the folder for you. Just make sure you're in the right folder where all your scripts and data are. To set the working directory with point and click, which I think is the easiest way to go, because sometimes doing it by code doesn't work for some reason. Go to session, set working directory, choose directory, and then choose whatever folder you want to work for the session. Okay, almost done, promise. So just a couple of tips when you're working through the scripts we've put out, if you haven't done all of them already. Don't run all the code at once. And I'm really bad at listening to my own advice, and I do this a lot, and then I break something, or an error code happens and you don't know where the error code is. So it really ends up going faster, even though it sounds counterintuitive, just like run one line at a time. And then it's much easier to figure out your errors, and it ends up saving you a lot of time. But will ignore this at some point, but just remember to keep going back one line at a time. If you run into errors, which you will, the best way to figure out what to do, which if you've done other coding, you already know this, is just to copy and paste the error into Google and see what comes up. That's what I will do. That's what any of the DNAC RAs will do if we don't already know how to fix the problem that you have. And likely you'll be directed to a site called Stack Overflow, which is where individuals and programmers post code questions and we'll get answers from the community. If you've done other coding work before, I'm sure most of you already know it. If you don't, it's free, extremely useful. I use it all the time. The best thing anyone ever taught me was one of my cohort mates who taught me how to ask questions on Stack Overflow in a way that does not make the programming nerds mad. If you don't make them mad, they will answer your questions very quickly, and they are very helpful. And last thing here, there are some resources that I personally use even when I need to go back to basic stuff, because I forget all the time how to do really basic things in R. There's some links. I don't think these slides are up yet, but I will post them or have Dana post them. And so there's a general guide to R that will go over some basic stuff that if you're teaching R, learning R by yourself, that will not be obvious. Our cheat sheets are just these one-page sheets on either specific packages or routines in R, like cleaning or merging data, since there's a million ways to do that. And then lastly, there's a faculty in the sociology department, Kieran Healy, who had a book come out last year on visualizations, and he has the entire book free online. And R is really fun to do visualizations in. And he does a really good job at walking through how to make your visualizations nice. And so this is the link to his book, which I find really useful when I'm trying to make visualizations, and very helpful for just showing information to people. I think that's all I have. So I'll stop for any questions. If anyone has any questions about Maria Christina's script or issues they've run into. And yeah, Jim, if you want to, if I left anything out.
I would just echo some points that I've heard other people make throughout, which is that many of us are migrating to R from other packages, from other routines, Data, SAS, SPSS, whatever you were taught in, and what you use commonly. I think that's fine. I still do a vast majority of my base data cleaning and recoding and this kind of stuff in SAS because that's what I'm most comfortable in, and I want my data to be right. So I can trust myself there. So that's what I do, much to the frustration sometimes of my RA. But I think that's the key point, is to make sure whatever it is you do in a way that is documentable and puts the primacy for accuracy over using whatever cool new tool someone else is using, and that's the key solution. Thankfully, many of these packages are becoming, or many of these programs are becoming more interoperable. So I know both Stata and SAS now have tools that allow you to engage directly with R from within their environment. Not quite as much vice versa, but it's again, I would just do that. And like any program you ever use, the more you use it, the better you'll be with it. So.
If I could offer a tip, if you do a hashtag in R and then type behind it, it will become a comment. So code that the program will ignore. And if you comment your strings, it makes it really easy to go back to older projects and be like, what was I thinking here? Or what does this variable mean? And things like that. And I know for me, that's always useful because I can write something one day, go back to it literally 3 hours later and be like, what is this? So I always try to comment stuff.
Amen. Amen. I can't tell you how often, I've gone back to old code and haven't been able to figure out what I'm doing. And so I've gotten to the point nowadays where unless I'm in the middle of just like, a massive rush to get something done, the goal is to have more comments than code. So you should essentially be describing the logic of what you're doing as you're doing it.
Also helpful if you have to submit reproduction packages. Otherwise you have to redo everything, and that's not fun.
Actually, on top of that, with the commenting, it's helpful to actually put the version numbers of the once, say you're about to submit a paper and you have the script that really supports that paper. At that point, it's useful to comment the packages and the version numbers of the packages that you used for that paper, so you can go back, because while R had, one nice thing about R is it has a collection of, basically you can get the old versions of the packages. So if you're really worried about reproducibility, you can pull that old package and run that. It is actually something to do. So and for communicating to other people, it's also useful, because as R updates and things like that, you might get the newest snazzy thing and then there's some slight differences in it or whatever. So it's just good to have meta comments like that at the top once you're finally at the point like, this is script that I expect that people might be interested in knowing how to reproduce the results from.
For those of you that might not be as familiar with R as others, the point of version numbers that John is pointing to here is there's often what are called package dependencies built into the package you're using. And because this is open source software and people are drawing on each other's work, if I change my package, it doesn't mean it's going to keep working with your package. And so these dependencies are version dependent often. And the backwards compatibility problem, as you update a package, a link to a prior package might break because they changed their package in a way that you don't expect. So it's not just like for documentation purposes, it's for actually going back and getting the darn thing to work again purposes. You need to know what version you have. Now, there are ways to roll up your whole environment and create a package, sort of a single file that holds all of those pieces in it, which is also a good idea.
Yeah, we went over all the code from last time we taught this course to make sure it didn't break or package hadn't been updated.
Any other code warriors out there who've had great tips? I really appreciate the swirl reference. That is I have seen that before. I'd forgotten about it. I just went and checked out the page. But any other tips or hints for people who haven't, from those who have to those who haven't? John, you have a set of blogs you like to follow, right?
Yeah. So two of them related specifically to R. There's R bloggers, which is my blog go-to source for how do I want to do something cool in R. And then there's R pubs, which is, okay, I've heard about some elaborate statistical technique, or maybe not so elaborate. And they have R pubs is very nice for actually laying out. They're more like scientific papers. So what is the assumptions of this method? Does my research question match those assumptions? R pubs is the place where you can actually get that kind of breakdown. R bloggers is, how do I make my ggplot look even more fun than it did before? So those are two really good resources. And from those, you can find community-based resources that might, like there's a really active community actually in epidemiology in R, and you can find, and the tree expands quickly. Or if you're interested in well, epidemiology, there's cognitive science, there's all sorts, there's like little R subdomains. So from R pubs and all bloggers, you could go find your community of interest within R. And that can be really helpful because they will bring things up, because R bloggers, you can get a like little email that has like highlights for each day. But once you sort of figure out your sub community you're particularly interested in, and actually let's bring that up right now. There's actually some nice sub communities for social network analysis. So there's a nice, we talked about, we're going to talk about StatNet and SCNA. There's like a nice little community that is behind that you can get onto their old school but still very useful listserv and follow what's going on with problems with that. And what's great about those communities is that you can also sort of figure out who kind of are the go-to people within these communities. And while you might not want to bombard them with questions constantly, like you can go, if you go, oh, well, all right, I know about R pubs and I know that Carter Butts is like one of the key people, or Kaminsky is one of the key people. Now I can search that name or two and I might get a couple articles that are super relevant to me, or just Google Scholar or something like that. So that's one of the nice things about community-based open source programming, is that often there's groups of people that are highly motivated to make your experience more enjoyable because they're committed to having this work in the future. So you're not actually alone. When I first started working R, I felt very lonely and very like, well, is this right? Am I not sure it's right? And in fact, finding these community resources have made that a lot easier.
Any other sort of basics questions or general programming questions? Please, Allison.
I just have a question about CRAN, because I think it was last night when I was loading some of these packages, it said, do you want to go back to the original source, which was CRAN, and it took a long time. Can you just explain what that is and why, Yeah,
I can jump in on that. So CRAN is the sort of definitive R source. It's because there is a set of standards that you have to meet to have your package supported by CRAN. So if you're really worried about reproducibility and stability, then the CRAN version of it is usually the thing you want. On the other hand, there are some packages that are still highly useful that they didn't want to do the PDF exactly in the right format to get onto CRAN, and so that's where I'm not sure we brought this up earlier, but you'll see a very useful package to have is called DevTools. And DevTools allows you to get packages that are being developed on GitHub. You can go, I would highly recommend anything you think that isn't from CRAN, go to their GitHub site and look at how well documented it is. You can tell right away if, is this something I actually want to invest my time in? But with DevTools, you can then pull things directly from GitHub. And there are times where basically it's a cutting edge thing. The authors haven't done all the PDF work yet. It's not quite on CRAN, but you might still want to do it. Or I have one example of my scripts later. I wanted word clouds that were easy to use. And so I went to the version that's word cloud 2, which the users for like 3 years just have balked at doing the PDF exactly right for CRAN. It's a fine package. So CRAN is nice because it's strong community standards and it will be reliable.
All right. Again, if this were a normal session, a normal year, we would be looking over your shoulder and running these scripts and these kind of things. That's a little harder to do in this format. But we're going to take a quick break. We'll come back in about 5 minutes and we'll talk about manipulating network data specifically in R and the ways in which that works. So again, just a quick break to grab a new cup of coffee or stretch your legs as you need to, refocus your eyes from the screen, and we'll be back in a moment. So 11:05, we'll start.